welcome to another WJEC A level physics question. This time it's question 2 from June 2006 as unit 1, and it's a Newton's law question. Now first of all, we're told that Newton realised that forces always act in pairs, and he used this idea to develop the third law of motion, and we've got to state that third law of motion. Now many people remember the third law as every action has an equal and opposite reaction, and that's perfectly fine provided you explain what the action and the reaction are. So it's easier to answer this question in the following way. So if we say something like, if object A exerts a force on object B, that's our action, then object B exerts an equal and opposite force on object A. That's our reaction. For the second part of the question, we've got a diagram where we've got a wooden block resting on a horizontal table, and underneath that we've got the block and the table drawn separately, ready for us to add some arrows to make these free body diagrams. But we're not going to draw all the forces this time, we're just going to be drawing the forces acting between the block and table. We've got to identify basically the third law, pair of forces acting between the block and the table. Well, the best way of describing third law pairs are to describe forces as pushes or pulls of one object on another. So here the force I've labelled is the push of the table on the block, or the force of the table on the block, or if you like, we could call it a normal reaction. And to get its third law pair, all we've got to do is swap the two names around. So here the pair will be the push of the block on the table. So once again, to get a third law pair, we just swap the objects around. Next we're told there's an applied force, F applied, exerted on the block, and there's a constant frictional force, F friction, equal to half the weight of the block. The block's got a mass of 0.5 kilograms and its acceleration is 4 meters per second squared, and we've got a diagram representing the forces and the acceleration. And next we have to calculate the frictional force. So we're told that that frictional force is half the weight. The weight is found by multiplying the mass of the block by g. So it's a half times 0.5 times 9.81. If we put that into a calculator to three significant figures, we get 2.45 newtons. This bit about referring to the data on page 2, basically many years ago, in 2 or 3 specs ago, instead of having a separate data book, the data was given in the front of the exam paper. Next part, we've got to write down an equation that links the applied force, the frictional force, and the resultant force. Now the resultant force is just basically the total of the forces acting on the object. But as we can see in the diagram, the applied and the frictional forces are acting in opposite directions, so we're going to take those forces away. And F applied must be bigger than F friction because the object is accelerating to the right. So we're just going to write this as F applied minus F friction. For the last part of the question, we've got to calculate the size of that applied force. Well, if we rearrange that formula, we're going to get that F applied is F resultant plus F friction. From Newton's second law, the resultant force is the mass, which was 0.5 kilograms, times the acceleration, which was 4 meters per second squared. And we've already worked out that the frictional force is 2.45 newtons. Well, 0.5 times 4 is 2, 2 plus 2.45 will give us a resultant force of 4.45 newtons. Thank you very much for listening. Please remember to like and subscribe, and feel free to ask any questions in the comments below. Goodbye.